All attendees are in listen-only mode.
Hello everyone, very good evening to all of you. Welcome. So, what is the topic today? Let me confirm. Is it average or numbers? I think it's number. Division and divisibility rules, exactly. Okay, so hello, good evening to all. Good evening, good evening. Okay, I hope it was not much of an inconvenience to all of you that I delayed the class for one hour by 1 hour. So earlier it was scheduled to start at 8, but I had some work, so I got free only by 9. Okay, let's start then. Okay, now let me start with an easier one right now. Divisibility rules. Okay, so divisibility rules mean an easier way to find out if a big number is divisible by your divisor or not. So we have divisibility rules of a few prime numbers, starting prime numbers, and the numbers made by them. So let me categorize them for you. So first 2 and 5. Okay, let me write a number for you. So let us say 2, 2, 4, 8, 4, 0. Okay, so needless to ask you if this number is divisible by 2 or not. I believe everybody knows this, that you only need to see the last digit, the units digit, to be able to decide if this number is divisible by 2 or not. So 2, yes. What about 2 square? 4. So when it is 2 square, you see last two digits for 2 square. Last two digits make 40. Is 40 divisible by 4? Obviously, yes. So it's divisible by 4 also. What about 8? That is 2 cube. When it's cube, we see last three digits. Last three digits make a number 840. Is 840 a multiple of 8? Yes, so the number is divisible by 8 also. Okay, what about 2 to the power 4? So you see, as we increase the power, the test starts taking more and more time for you to find out. Now, what if the number itself is a 3-digit number and you are asked if it is divisible by 16? So 16 is 2 to the power 4. You need to see last 4 digits. If the number itself is 3-digit number, you have no divisibility rule. You only have to divide the number. Okay, last 4 digits make 4840, 4840. So you know 48 is divisible by 16, but 40 is not. So the number is not divisible by 16, and hence there is no point testing further. So our number is divisible up to up to 2 to the power 3. Okay, another thing. So this 4840 what remainder will it give when it is divided by 16? I think it will give a remainder of 8. So the good news is that the entire number will also give the remainder of 8 when divided by 16. Hmm. All right. So, okay. So the shortcut of this, the shorter version of this is, suppose there is a number, 785. Now you know that this number is not divisible by 2. Fair enough. So for 2 we see only the last digit, 5. So if you are asked what remainder will 785 give when divided by 2, you know the remainder is 1. Okay. What about 2 square? 85. So 2 square is 4. When you divide by 4, there could be 4 remainders. 0, 1, 2, 3. How to decide? So you just divide the last two digits by 4. Whatever remainder you get, that will be the remainder when you divide the entire number by 4. So whatever remainder 85 gives when divided by 4, the entire number 785 or say 3785, whatever be it, that also will give you a remainder of 1 only when divided by 4. Similarly, when last three digits were tested, so 785 definitely is not divisible by 8. What remainder will 785 give when divided by 8? So 65. Okay. So 8 8 is 64. One remainder. So 8 also gives one remainder. Then entire number 3785 will also give one remainder when divided by 8. Alright. So I hope you got the point. Okay. Fine. Why did I write the divisibility tests of 2 and 5? Because you know what? The divisibility rules of 5 also go exactly like this. So when you have to check by 5, you know you'll see only the last digit. If the last digit is 0 or 5, the number is divisible by 5. Okay. When it comes to 25, that is 5 square, you check only the last two digits. If the last two digits, that is 40, if 40 is divisible by 25, then the entire number is divisible by 25. And if not, then whatever remainder 40 gives when divided by 25, the entire number 24840 will also give the remainder of 25 only when divided by 25. Okay. So similarly, oh, if it is not divisible by 5 square, so there is no point checking with 5 cube. But you do know that if you need to divide, if you need to find out the remainder when you divide by 5 cube, you just need to pick last three digits, divide it by 125 and find out the remainder. The remainder in that case will be 90. So you will say the entire number will also give the remainder of 90 when divided by 125. Alright. Okay. So far, so so far we saw that the number is divisible by 2, 2 square, 2 cube in the line of twos, and it stopped after 2 cube. 5, but not 5 square. Okay. So if the number is divisible by 2 as well as by 5, it is divisible by 20. If it is divisible by 4 and 5, it is divisible by 4 and 5. Sorry, earlier it was 10. If it is divisible by 2 and 5, it is divisible by 2 into 5. If it is divisible by 4 and 5, it is divisible by 4 into 5. If it is divisible by 8 and 5, it is divisible by 8 into 5. So till now we have found that the number is divisible by 2, 4, 8, 10, 20, 40 and 5 obviously. All right. Sorry. Okay. Similarly, next we see divisibility rules of 3 and 9. So like the rules of 2 and 5 were similar. Similar are the rules of 3 and 9. So if suppose we have to check 24840 whether this number is divisible by 9 or 3 or not. So what do we need to do? We need to find the digit sum. Digit sum is going to be a little different from the sum of the digits. Digit sum is a little different from sum of the digits. How? Okay, so sum of the digits is 2 plus 4 plus 8 plus 4 plus 0, needless to write, which is 18. Now digit sum, I need to add 1 and 8 also. I got 9. If the digit sum of any number is 9, only then is it divisible by 9. And if it is divisible by 9, it is definitely divisible by 3. Okay, so let me write that rule for you here. Okay, so you may also make a note of this with me. So keep adding the digits of the, oh no. So keep adding the digits of the number successively until you get a single digit as the final sum. Thing we did with 24840, we added all the digits, we got 18, we further added 1 and 8 until I got a single digit which was 9. Okay, so rule number 1. Oh, sorry. Rule number 1. Second, if the final sum is 9, only then is it divisible by 9. And obviously by 3 also. If the final sum is not 9 but 3 or 6, then the number is not divisible by 9 but is divisible by 3. Fourth, if the final sum is anything but 9, that would be the remainder if the number be divided by 9. Alright, last line has been cut. Let me write it again for you. So you please note this down and I'll give you examples for this. Yeah, okay. So now let us understand one by one. So if the number is, so if the number is 375, let's find the digit sum. What is the digit sum? 7, 5, 12, 12, 3, 15. 15 is 6th again. So digit sum is 6. So this number is not divisible by 9, but is divisible by 3. Okay, so this is what rule number 3 says. And the previous example is what rule number 2 says. Now let us see. Okay, 676. What is the digit sum of this number? So 6 plus 6, 12 plus 7, 19. 19 is 9 plus 1, 10. 10 is finally 1. So 1 will be the remainder if the number is divided by 6, sorry, 9 or by 3. Okay, let us check quickly. So if 676 is divided by 9, what do I get? 9 7 63, 46, 9 5s are 45, 1. Oh, it worked. So we didn't need to actually divide the number by 9. We only found the sum of the digits, the digit sum, and we got the remainder. So what if there is a big number, say 3 2 7 9 8 1 4. Okay, so let us find the sum. So 3 plus 2 5, 5 7 12, 12 and 9 21, 21 and 8 29, 29 1 30, 30 and 4 34. So 34, we need to add 3 and 4 also, we get 7. So 7 will be the remainder if the number is divided by 9. So this one I am not going to show you, you have to check yourself. So divide 3, 2, 7, 9, 8, 1, 4 and see for yourself that the final remainder comes out as 9. So take 30 seconds or 40 seconds to do so. Fine, done, checked. Okay, Padmanabh has a problem. He got 1 as the remainder. How come? Okay, let us check. Okay, so 9, 27, 57, 54, 39, 36, 38. Let's continue here. 38, 36, 2, 21, 18, 34, 27. No, it is 7. It has to be 7. There is no exception to this rule. It will always work. Oh yes, it will give you the remainder of 1 when divided by 7. Because when you divide by 3, 7 cannot be the remainder. Okay, so when you got 7 as the remainder when divided by 9, so you divide 7 by 3 and find the final remainder. We will work on it. Do not get too confused right now. Okay, this was the point. Okay, so 3 and 9 done. Alright, so we got that, we found that this number is divisible by 3 and 3 square also. So if it is divisible by 2, 5 and 9, it is divisible by 90. If it is divisible by 8, 5 and 9, it is divisible by 360. So without actually checking by such big numbers, we can actually declare that the number is divisible by such big numbers. So any combination that you can make using one of the 2's column, one of the 5's column and one of the 3's column, any combination that you make, so whether it is 8 into 5 or 4 into 9 or anything, the number will be divided by that. Okay, so from 1 to 12, 1 to 11, we got the divisibility set rule set of 2, of 3, of 4, of 5, of 6. How 6? Because 6 is made up of two prime numbers 2 and 3. So to be divisible by 6, the number has to be divisible by 2 and 3. So when it is a composite number or non-prime, we just check that what the number is made up of. So suppose you want to find out if the number is divisible by 24 or not. So we quickly do the autopsy of 24. We write 24 as the product of prime numbers. So I find it is 8 into 3. Is my number divisible by 8? Yes. Is my number divisible by 3? Yes. So the test passed. So the number is divisible by 24. So 24840 is divisible by 24. Are you getting this? Can we move ahead? I think so. Right. Alright. Now the divisibility test of 7. So, I have to tell you, so I will tell you. But I honestly feel that, yes, Abhishek, I can surely repeat, but please tell me what to repeat. I think the composite number part you are asking. So I said, if you want to find out if a number is divisible by, say, 60, so you do the prime factorization of 60. Do not write 60 as 12 into 5 or 10 into 6. Write the entire prime factorization. So 60 is made up of 2, 3, and 5. No other prime number is involved. So it's 2 square into 3 into 5. So for the number 24840, for this number I wanted to check if it is divisible by 60. What I will see, is it divisible by 2 square? Yes. Is it divisible by 3? Yes. Is it divisible by 5? We already checked all these. So the number will be divisible by 60. Okay, Padmanabh's question is, what is the difference between sum of the digits and digit sum then? Okay, so so 2604198. So sum of the digits for this number is 34, but the digit sum for this number is 7. So we just add all the digits, plain and simple, as we always thought. So that is the sum of the digits. But digit sum is when you further add the digits of the sum of the digits. So you keep adding until you get a single digit. Alright, so divisibility sum of rule of 7. So yeah, I was saying that the divisibility rule of 7. So the divisibility rule of 7 is so pathetic that you would feel it easier to actually divide the number by 7. So let me take a number 3, 5, 2, 1, 7. How much time do we need to actually divide the number by 7 when we really are not bothered about the quotient but only the remainder? So we know 35 comes in the table of 7, then 21 also comes in the table of 7, then 7 also comes in the table of 7. We saw that. It hardly took us 10 seconds to find out if the number is divisible by 7. Okay, now what the rule says, rule says that detach the last digit from the number and subtract the double from the remaining number. So I detached 7, doubled it, and now I am subtracting it from the remaining number. I get 3507. Okay, do the same. 350. Now detach 7 and subtract the double from 3507. So I am now subtracting 14 from 3507. What do I get? 3493. From 3493. Oh, sorry. Big mistake. So when I detach 7, I had to subtract it from 370. So subtract the double of 7 from 370. So I get 356. So from 356, detach 6, and from the remaining number, subtract the double of 6. What do I get? 23. Oh no, again a mistake. Sorry. My bad. Okay, let me take it again. You must be getting confused by this. Okay. Okay. Telling you the rule again. So detach the last digit from the number and subtract the double from the remaining number. So from 3, 5, 2, 1, 7, I detached 7 and subtracted 14 from the number. I got 3507. From 3507, I have to detach 7 and subtract double of 7 from the remaining number, that is 350, which is 336. From the remaining number 336, detach 6 and subtract the double of 6. What do you get? 21. And then check if 21 is divisible by 7. If it is, the answer is yes. If it is not, the answer is no. So the rule is really time taking, confusing, stupid. So I honestly admit that I have remembered this rule only because people keep asking me time and again that, sir, you have not told the rule of divisibility by 7. So if they insist so much, I have to tell them. But otherwise, it's not practical. I don't think, I never use it. I simply divide by 7. That is much easier. So on one hand, we have a rule of 9, which is so handy, which is so easy, which is so time saving. And on the other hand, there is a divisibility rule of 7, which is much more time consuming than actually dividing by 7. So this was the story of divisibility rule of 7. So imagine divisibility rule of 13 and 19. They are further more difficult. Okay, in between, there is one more divisibility test, which is very interesting, exciting, and a lot of questions are made on that. Okay, so let us find out the divisibility rule of 11. Let's come back on our number 24840. What do? I make a group of alternate digits and add them. So 2 plus 4, sorry, plus 8 plus 0, and the other pair of alternate digits. So 4 plus 4. What do we do of these two groups? We subtract. What do we get? 2. So we say the remainder will be 2 when 24840 is divided by 11. Fine. So this is the rule. Let's take another example to better understand. So now let me take an example. So what about 14641? Let me make a group of alternate digits 1 plus 6 plus 1. Let me make a group of another alternate pair of alternate digits and I get 0. What do I understand? The remainder will be 0. So the number is divisible by 14641. For your information, this is actually 11 raised to the power 4. Okay, let us take another number. So 2090. Okay, so let's make a pair of alternate digits and the other pair of alternate digits is simply 0. So we got 11. So remainder when you divide by 11 cannot be 11. So 11 coming a remainder of 11 means the number is divisible by 11. Okay, let's take one more example. So 1, 4, 1, 9, 2 minus 13. I got minus 11. In this case also the number is divisible by 11. So in short, when you do this business of discriminating the digits into two groups of alternate digits each and subtract them, if you get 0, 11 or minus 11, you get the number divisible by 11. And if not, then whatever be that difference, that becomes the remainder. Okay, so let us check. We have already found 24840. The final difference was 2. Let us check if 24840 is divisible by 11, and if not, what remainder is it actually going to give? Okay, so 22, 28, then 22 again, 6, 64, 55, 9. Let's continue here. So 90, 88. Yes, the final remainder was 2. No, Shivangi, if the remainder is a multiple of 11, uh, no, then it will not work. I mean, it will work, but we will talk about it. What happens when the remainder comes out to be greater than the divisor? We will talk about it. So you will get your answer maybe in a while. Okay, so ready for a question? Okay, first question is going to be an easy one. So, so 4, 5, x, 3, 1. If this number is divisible by 11, then what should be the value of x? Okay, Chandra Kamal asked what if the difference is negative? That also we will cover in the section of remainders. What happens when the remainder is negative? What happens when the remainder is greater than the divisor? All that you will understand. Okay, 4, 5, x, 3, 1. So if we make two groups, we get 4 plus x plus 1 minus 5 plus 3. What do I get? I get x minus 3. Okay, so this x minus 3 should be 0, 11 or minus 11, out of which the cases of 11 and minus 11 will not exist eventually. Why? Because to make x minus 3 to be 11, x has to be 14, but x is merely a digit. It cannot be 14. So x has to be 3, 14, and minus 8. Digit cannot be negative, digit cannot be 14. Digit has to be from 0 to 9. There is a unique answer 3. Alright. Okay, a little better question now. If 3ab 7, 5. If this number is divisible by 11, you are told that this number is divisible by 11. Find the value of a plus b, minimum possible and maximum possible. Minimum possible and maximum possible values of a plus b. Try out please. This one is of average level, not of easy level. Okay, I think a lot of you have tried and gave me the answers. Okay, so I've got a variety of answers. One answer is 1 and 17. One answer is 0 and 9. Yes, Uday, 3AB75 is divisible by 11. One answer is minimum -1 and maximum 7. Okay, so a lot of answers. Let us check. Fine. So our number 3AB75. Let's make the two groups. Two groups are 3 plus B plus 5 minus A plus 7. What do we get? We get 1 plus B minus A. Okay. Okay, so 1 plus B minus A is supposed to be minus 11, 0 plus 11, which means B minus A is supposed to be minus 12, minus 1, and 10. Out of these three possibilities, minus 12 is out of question because difference between two positive digits cannot be minus 12, neither 10. Yes, it could be 1. So if b minus a is supposed to be minus 1, that means b is 1 less than a. So that means b and a could be 0 and 1. I think this will give you the minimum possible value, which is 1. And 8 and 9, which will also make minus 1, will give you the maximum possible. Is that understandable? Waiting for your remarks. You may note down. You may also want to write some statements along with the solution, because I don't write, so I only speak. Okay, a lot of requests to repeat, so let me do so. So I hope that till this point everybody understood that b minus a should be minus 12, minus 1, or 10. Do I need to start before this point? Please guide me, guys. Okay, okay, okay. So, okay, let me start from here. So, basically, I got the two groups. I got 1 plus b minus a to be minus 11, 0, 11. So, accordingly, b minus a became minus 12, minus 1, or 10. Okay, so minus 12 is not possible because b and a are only digits. B could be, between 0 and 9 inclusive, and a also could be between 0 and 9 inclusive. So, there is no possibility that b minus a or a minus b could become 12 or 11 or 10, or are you getting it? Okay, so for b minus a to be minus 12, or basically a minus b to be 12, a and b have to be at least 12 and 0. How can a be 12? A is a digit. A digit cannot be 12. A digit is only among 0 to 9, right? Similarly, when the difference is 10, had the sum been 10, it would have been a different story. But here the difference is 10 or 12. A and B are digits, not just integers, which you can put anything. Okay, fine then. So there can be great questions on divisibility rules, but this is an MDC class, and I have to limit the level of difficulty till here. We will do a lot of workshops and cat questions and all. We will take a lot of good questions over there. Now my next section, division. So what possibly can I tell you in division? Division is taught in class 1 or 2, I suppose, right? But you will be surprised to see that there are a lot of things that we have been um, ignoring about division. So let me divide 100 by 7. So 1498, and I get 2. Okay, so let us do the naming thing first. 7 is called, let me typing is faster. Okay, 7 is called the divisor. 100 is called the dividend, or simply the number. Okay, 14, we all know what it is called. It is called the quotient. and 2 is called the remainder. Very important, most important. So I am changing the color of remainder just because this entire story is going to be revolving around remainder. Okay, so now we got 2 as the remainder. What is the importance of remainder? We have been ignoring remainder since our childhood. We have always been very curious and emphasized, focused about finding out the quotient only. But there are a lot of things which depend on remainder. For example, let me make a few questions and a few stories out of this division. So, disclaimer is, guys, you may want to note down a couple of things while I'm speaking because there is a lot of speaking and explaining and less of writing. Okay, and the recorded video of this class will also be available on uh, the chosen channel by Mindworks. So you may want to hear it again to make notes. So right now your focus should be only on understanding. Okay. So let me make the first story. So the question is, what day of the week will it be after 100 days from today? Or what will be the 100th day after today, the day of the week? So today is Monday. Today is Monday. So 100 days later, what day will it be? So I quickly divided 100 by 7 to see how many weeks are there in 100 days. I got 14 weeks. The quotient is 14, so I got 14 weeks. Okay, then I got a remainder of 2. Had I only got a quotient and no remainder, I would have immediately said that the answer is Monday. There is going to be 14 complete weeks. So the answer is Monday. But no, here I got a remainder also. And this remainder will change the answer. So this 100 days, because of division by 7, it got me 14 weeks and 2 days. These 2 extra days is going to make Monday to Wednesday. These 14 weeks do not matter. Had they been 13 weeks or 3 weeks or 1 week or no week or 2 weeks, doesn't matter. What matters only for this answer is this 2 remainder. So हम कहेंगे कि जो परसों है वही 100 दिन बाद होगा. Whatever is going to happen day after, the same day will be there 100 days later. Fine. Okay. Alright. So another story. What should be subtracted from 100 so that it became divisible by 7? Again, having no idea, I started dividing 100 by 7. I got 14 as the quotient and 2 as the remainder. Okay, so 14 is the quotient, that is fine. But the thing is, if I want a number to be divisible, I don't want a remainder. I got a remainder of 2. Remainder of 2 means extra. 2 is extra. So if I just subtract this 2 from the dividend, the remaining number will be divisible by 7. So try and subtract 2 from 100 and see the remaining number 98 is divisible by 7. Yes? Okay. Let me make another story. So we had 100 toffees and we wanted to make small packets of 7 toffees each. This division tells me that there will be 14 packets made. Okay, so 100 toffees, the other example, pardon the horrible handwriting. It is difficult to make a good handwriting on a digital pad. Okay, so 100 toffees when divided by 7 told me that successfully 14 packets can be made, and plus there will be 2 extra toffees. Okay, so 14 packets and 2 extra toffees. This tells me that in the process of making 15th packet, I just could not make it because there were only 2 toffees left. Can I also say that I got short of 5 toffees in the process of making the 15th packet? I think so. Okay, so all right. So we understood that the following things. One, that when a number n is divided by a divisor gives a quotient of q and a remainder of r, then one thing is for sure, we can write n as dq plus r. Check this. In the above example, when 100 was divided by 7, is 100 7 into 14 plus 2? Yes, it is. Second thing, when this r is subtracted from n, the number is a multiple of d. Yes, the number is divisible by d. Okay. Now let me do this division again. So I am just taking this division over here, and sidewise I will do another division. Same thing. I am going to divide this 100 by 7. And this time I am going to do something that we were told not to do when we were children. Now I got -5 as the remainder, which we were asked not to do. We do not get remainders negative, which is true. And even now, when we are asked the value of the remainder, we never give a negative answer. We never give a negative number as an answer. Okay, so when we are asked to divide a number by, say, 9, we never say -8 is the remainder. We say +1 is the remainder. Okay, but there is some other reason that I uh, took this example, because of which. Okay, so I made 3 stories. Let us see and check the 3 stories one by one in this second form of division. See, technically I did not do anything wrong. I divided the way I should have. I did not do any calculation error. It's just that I have divided it by a number greater than, multiplied it by the number to make a number which is greater than 100. Okay, so first story was, what day of the week will be 100 days from today? So the second division tells me that go -5 days. So from the 15 weeks, I have to subtract 5 days. To the 14 weeks, I had to add 2 days. From the 15 weeks, I have to subtract 5 days. Let us subtract 5 days from today. Last time, when the remainder was +2, we added 2 to Monday. So we got Monday plus 2 and we got the answer as Wednesday. This time, let us subtract 5 from Monday, and do we still get the Wednesday? Yes, that means it is working. No? Yes. Okay. Apurv Babbar, you asked me, can you please explain the third division again? There have been only two divisions, Apurv, not the third. Pramit, it would be Wednesday. So when we say 100th day from today, we start counting from tomorrow and we include the 100th day. So we start counting tomorrow as 1, day after as 2, day after as 3, and so on. So the 100th day that we land upon is going to be Wednesday. Okay, second division, I believe the one in which we got negative remainder, right, Apurv? Okay, so if you want me to show you the division, I can do so. So I directly wrote the answer over there. If I had to like divide like this, so instead of writing 4 and 28 in the downwards, I write 5 and I write 35 over here. So I do all the calculations right. It's just that टेबल थोड़ा ज्यादा पढ़ लिया, वहां तक चले गए. अभी ठीक है अपूर्व? इज इट ओके नाउ? Okay, all right. So, so the first story was 100 days from today. We divided by 7 twice. One time we got a remainder of 2, so we added 2 to Monday. Apurv, I did it purposefully. I could have just divided it the way we all do and we all should. I am just trying to make a point here that negative remainders are something that are not presentable, but they always keep working and they do exist. Okay, so let me try to make that point. So, okay, so first story is this. Second story, that when we subtract remainder from the dividend, the number is divisible by the divisor. So last time we we subtracted 2 from 100, we got 98, which was a multiple of 7. This time the remainder is subtracted, so minus 5 will be subtracted, and I will get 105, which is also a multiple of 7. Interesting. No, Uday, the application of this is not only for calendar problem. There are many applications of this, and in number system, it is extremely important to know the concept of negative remainder. Okay, coming back. So the second story was, and the second conclusion was, if remainder is subtracted from the number, the remaining thing is divisible by the divisor. This part, which I wrote technically as n minus r equal to dq. Now, with the example, so when remainder was subtracted from the dividend, so 2 was subtracted from 100, the remaining 98 was divisible by 7. Now, when the remainder is minus 5, when minus 5 is subtracted from 100, I got 105, and the answer is it's still divisible by 7. So the second story also works. The second test is also passed. Okay, the third. when 100 toffees implied 14 packets and 2 extra. Now 100 toffees imply 15 packets minus 5, which is also working. So for 15 packets, I had to take a loan of 5 toffees from somewhere, or I fell short of 5 toffees in this arrangement. So any of these things is explained by the negative remainder. Okay, this is just an introduction of negative remainder. Maybe later Arun Sharma sir or Lokesh sir or even I, if we take the proper class of number system, you will see amazing applications of negative remainders. So this is just a heads up. You should know what a negative remainder is, or suddenly if some faculty started using this, you would be like in a fix. आपको समझ में ही नहीं आएगा कि क्या हुआ, कहाँ से हुआ, ऐसा तो कभी कुछ देखा ही नहीं था. So negative remainder is something that is not officially presented as an answer ever, but always works in every division. Okay, now what is negative remainder? Let me finally explain this to you. For this, we have to actually understand. Yes, Srishti, there will be not one class but classes related to remainder. Remainder is treated as a chapter in number system for cat. So there will be a particular class on remainder. There could be more classes, more than one classes dedicated to remainder problems taken by Arun Sharma sir or maybe by somebody else. So he will take various examples in which he will tell you how to quickly find remainder when impossible looking numbers are divided by numbers, like what if 25 to the power 25 is divided by 7, what will be the remainder, or what if 7 to the power 7 to the power 7 when divided by 25, what is the remainder. No worries, Gopal. If the remainder theorem has been done for old students, it will be repeated. Nobody uh, will be lagging behind. It's just that once your basics are done and you start understanding, catching up with the topics, and then the regular class will be done for you. Okay, so let me go ahead with the topic. So, when we learned multiplication, we were told, or we learned on our own, that multiplication is actually addition. So when you were asked 3 into 7, you knew it is 7 plus 7 plus 7. It is actually addition. Multiplication is just a shortcut of addition. Or you added 3, 3, 3, 3, 3, 7 times. So multiplication is a technique to add numbers, the same number several times. But nobody told us that similarly division is also subtraction. So when we divide 100 by 7, this is equivalent to subtracting 7 from 100. So this tells us we can subtract 14 times. We can subtract 14 times from 100. Okay, so division is simply subtraction. Remember the story of making toffee packets? So when we made the first packet, we subtracted 7 from 100 toffees. When we made the second packet, we subtracted 7 from 93 toffees, the remaining ones. So after subtracting 7 from 93, I get 86. Further, I can subtract 7 from 86 and get 79. Further, I can subtract 7 from 79 and get 72. So keep moving by 7 and finally I'll get 2. So division is basically subtraction. Exactly like multiplication is a form of addition. So if we understand division like this, we will have an entirely new point of view and approach towards division questions. So let us see, when we divided 100 by 7, or in other words, when we subtracted sevens from 100, we got 2. And if I subtract it one more time, I get -5, which is the case of negative remainder. Okay, so the positive remainder, the negative remainder, and the divisor are connected through this dot. So remainder minus divisor, you get negative remainder. So whenever in future you incidentally get a negative remainder, just quickly add divisor once or twice, whatever the number of times needed to make your answer official. So suppose by some logic, by some technique, by some formula, you were dividing a big number by 19 and you got -8 as the remainder. So -8 you will not find in any of the options. So negative remainders are not presentable. When you are asked remainders, you have to give positive answers or non-negative answers rather. So by some technique, by some logic, by some formula that you will learn in near future, you got the remainder -8 when you were dividing by 19. So what you will quickly do, you will just add 19 to -8 to make your remainder positive. So you converted -8 into 11 by adding 19 to it. I hope you guys are making notes of this. Okay, so okay, let me take a fresh example. So what least number should be added? Okay, let me ask this way. What are the smallest 5 digit and greatest 4 digit numbers which are divisible by 13? Okay, this is the question. So the smallest 5 digit and the greatest 4 digit numbers which are divisible by 13. All right. So what smallest 5 digit number do I know? I know the smallest 5 digit number as this. Okay, so if I divide by 13, I have no clue what number is it going to be. So they asked the smallest 5-digit number. The smallest 5-digit number that I know is 10,000. Let me just divide 10,000 by 13. I might get some idea. So 13 into 7 is 91. 9 remainder, 90. So 13 into 6 this time, which is 78, which gives me 12 remainder, and the last 0 comes on board, 120. So 13 nines are 117. I got 3 remainder. Okay, which means 10,000 minus 3 will be divisible by 13, right? So the answer to the first question is 9997. So I subtracted 3 from 10,000, and the answer to the first question comes out as 9997. Okay, so if the remainder is 3, so what is the negative remainder? Without dividing also we can find. What is the negative remainder? Subtract 13 once more. Subtract the divisor once more. I got the negative remainder as minus 10. Oh, yes, you are right. Okay, so this is the answer to the second question then. I got the answer to the second question first because I started with the smallest 5-digit number. So when I got an opportunity to subtract, it will not remain a 5-digit number. Yes, it is the largest 4-digit number. So the second question has been answered first. Okay, here I was trying to make the negative remainder without actually dividing. We just learned above that if you subtract divisor once more, it becomes a negative remainder. Alright, so now the negative remainder is 10. Further, from the number, if I subtract the remainder, I should get a multiple of 13. So 1, 0, 0, 1, 0. This should be a multiple of 13, and yes, it is. So the answer to the first question is okay. So now you get the right that if you want what should be subtracted, so subtract the remainder. If you want what should be added, then add the difference between remainder and the divisor, or simply subtract the negative remainder. When it is negative and you are subtracting it, in the end you will be adding something. So if the question is asked what minimum should be added to 10,000 to be able to divide by 13, you divide 10,000 first by 13. Whatever remainder you get an idea of the answer to the question. Alright guys, so I think I can stop here because no point starting a new topic. Uh, it will not remain fresh the next time we resume. And I think I tried my best to explain the process of division, like technically what happens inside a division and all. And I hope you understood at least a little bit. But if you just write all this again, make a good note of it, You may want to see this video again to be able to understand this much better. Okay, because division remainder questions can be very very easily tackled, very very fast done in the exams if they appear, and also there are applications of remainders here and there. So please take it a little seriously, and there could be more things related to remainder and division. So you do not want to just study them because there are chances that the question will appear in exam, but also it has a lot of applications. Okay, so thanks a lot for joining. Thanks a lot for learning patiently, and here we call it a day. Thank you so very much. Take care and good night.